and start. The topic is pretty simple. It's about concentration, obviously, and I'm not going to go through like all of the text from the book because, I mean, you can go and read that yourself if you want, and I can pretty much sum it up a lot quicker. So basically, concentration is a measurement of the amount of solute per solvent. And I'm going to explain two different quantities to measure concentration in. That is going to be molarity and molality. They're very, very similar, but they represent two different quantities, like I said. The quantity, quantity. So we have molarity. Let me fix that because the only difference between the two is whether there's an R or an L. Molarity. So molarity is abbreviated with a capital M, and you have molality with an L, which is abbreviated with a small m. They are both measurements of concentration, and they're almost the same except for molarity is moles of solute per liter of solution. That's how I abbreviate solution. And molality is, again, moles of solute, but instead this is kilograms of solvent. So they're very nearly the same, except for we've got liters here and kilograms. Now, the main difference, I guess, is if you have, say, you're making a solution and you are measuring the concentration in molarity, then you would measure out the amount of solute that you need, and then you would fill that with your solvent until the entire volume reaches 1 liter. And the reason why that makes a difference is because a lot of times, like if you've got your volumetric flask, which is this one that has a very skinny neck, and then it comes down and it's like a really round, oh, that's a terrible drawing, but anyway, a really round bottom and the flask. And usually there's a line here because these are used for dilutions. And so they have specific volume. So let's say this is a 1 liter volumetric flask. Then you would add your 1 mole. Sorry, it depends on what your concentration is, but let's say it's a 1 molar solution. Then you would add your 1 mole of solute, and then you would fill it until it gets to that line here. And the reason why that has to be specified is because you don't add a liter of solvent, because then you would have more than 1 liter of solution, because that solute also takes up volume. So that's the biggest difference. I do believe on one of the worksheets that I'll give you, there will be a question about that. Like when you make a 1 molar solution, do you just add a certain amount of solute and then add 1 liter of solvent? And the answer is no, because the solute does take up some volume. Whereas with molality, you have your measured amount of solute, and you do add your solvent by kilogram. Now, when it comes to application, there's going to be only one topic that we're going to discuss in chapter 13. Yeah. In the next chapter, I'm going to talk about colligative properties, which are properties that exist independent of what the solute is. And that, the concentration for molality in colligative properties is measured in molality. Colligative. Oops. So that's something we'll discuss in the next chapter. But to be honest, it'll be the only other time that we will discuss concentration in molality. Every other time that you see concentration, especially when we get to chapters 14 and 15, when we deal with acids and bases, it's always going to be in molarity. So this is the most common form of measuring concentration. The other thing is if you see square brackets as a measure of concentration. So let's say I've got NaCl in brackets. This is representative of molarity, the square brackets. So I'm going to just do a couple of questions. So let's say you have 3.40 liters of solution that contains 90.0 grams sodium chloride. What is the molarity of that solution? Okay, so you're going to have to put your last year skills to work because it's asking what is the molarity? That's the key word. So they're looking for something in moles per liter. So you're looking for moles of solute, and here you've got your liter of solution. And the only other piece of data you have is the mass of sodium chloride. So based on your knowledge from last year, if you see grams, the first thing you're going to do is what? Change grams into moles, which is what I taught you last year, and that still applies. So you're going to, the easy way to set this up so that you don't have to do too many different separate calculations, I like to do as little work as possible, right? Why is my computer not charging? Oh, that's interesting. All right, never mind. Okay, so what you have to do is basically what I would do is I would put 90.0 grams and my solute of sodium chloride, so that's NaCl. I'm going to put that straight on top of my volume of solution, and then I'm just going to change the grams to moles using molar mass. So I need grams of NaCl on the bottom. 1 mole goes on top. And then I have to go to my periodic table. So let's open that up just as a review. So I've got sodium, which is 22.99. So I'll go back here. And I've got 22.99, and I have to add that to chlorine, which is 35.45. And now I got to get out my calculator, which is somewhere else. Nope, not there. Here. Go back here, open up my calculator. No. All right. Oops. So 22.99 plus 35.45, and I get a molar mass of 58.44. And then I can just go ahead and cut my grams. And so now you can see that the units that I have left over are moles per liter, which is molarity. So I can go ahead and just do the math. So I've got 90 divided by 3.4 divided by 58.44, and I got 0.45. I can make the calculator go away. So 0.45 molar. Okay, so it should be pretty straightforward. And let me find. All right, a practice problem for molality, which again is moles per kilogram. And I've got a solution was prepared by dissolving 17.1 grams of sucrose in 125 grams of water. And then what is the molality? Okay, so again, we have our measurement of concentration, which is molality, which is moles per kilogram. I'm given the solute, which is sucrose. If you don't know or you don't remember, sucrose is C12H22O11. I'm given the grams of that, so I'm going to change that to moles, and then I'm given the grams of the solvent, which I can very easily divide by 1,000 to make it kilograms. So again, I'm looking for molality, which is small m, and I'm just going to start by putting 17.1 grams C12H22O11 per. I'm just going to change it straight to straight to kilograms to make my life easy. And oops, multiply. I'm just going to change that to moles. Grams C12H22O11. Okay. Now, I am just going to calculate the molar mass of sucrose. So I've got carbon, which is 12, mass of 12, and there are 12 of them in the formula. And I add that to 22 hydrogens, which is 1.01 times 22. I'm going to add that to 11 oxygen, and each one is a mass of 16. So I get 342.22. You see that the grams cut, and what I'm left with is moles per kilogram, which is molality. So then I just do 17.1 divided by 0.125 divided by 342.22 equals, and I get, basically I'm going to round that to 0.4. 0.4 molal.